Hello, everyone. Welcome to this session. The session I'm going to take today is going to be on quadratic equations. So, quadratic equations, that is, they're going to deal with some variables and some polynomials and so on. So, the idea is that this is going to be mostly conceptual, the basics, and then maybe a couple of examples. But do watch the complete because I hope you will really be able to understand it well. Okay, so let's start the session. Uh, I think I'll just give you one idea, which is about polynomials, of course. So I'm not sure if all of you do understand polynomials very well. So what's a polynomial basically? If you think of polynomials, it has to have variables, constants, and also the variables can have exponents and so on. So imagine if I write x to the power 4, I can call it as a monomial. And if I add one more term like x to the power 4 plus 2x squared, now this becomes a binomial. And as you can see, the word mono, the word binomial, and then you can also have, as you can probably guess, trinomial. So I'll just add one more term. So 2x squared plus 3x plus 3x square and so on. So the moment I add one more term, and these cannot be added, right? You cannot add x to the power 4 with x square something because these are like this is apple and this is something like guava or oranges. So you cannot add apples and oranges. So this will be written as x to the power 4 plus 2x square, right? So there are two terms. And one more thing, the moment you notice something that is like 2, and then also you have a 3x square and 2x and so on, we call this as coefficients because they are like it's basically 2 into x. That means you are multiplying this variable x with 2. And wherever you see this, we can call them as coefficients. Now, what happens if I add one more term? One more term, add or minus is same thing. So if you add one more term, it again becomes polynomial, of course, but with four terms. Now, technically, all of these are also polynomials because they do not have a single term. They have much more than one term. So we can call them polynomials. Now, this tells me that any equation, any expression where you have two or more terms can be called as a quadratic. Now, you remember if I write something like x squared plus 2x plus 4, this is also written as x plus 2 whole square. Now, notice that this polynomial, because it has three terms and has variables and constants, we can call them as a polynomial. But you will later on find out that this also is the standard form of what I'm going to tell you is a quadratic equation. Okay. And this is the standard form of a quadratic equation. I mean, this is when I say x squared plus 2x plus 4, it has basically three terms. It has a coefficient 1 here, it has a coefficient 2 here, and this is the constant term. So just hold on to this. I'll shortly come back. I have something beautiful. Now, what is that? I am going to tell you an example. So suppose this is a river and you decided to go on a cruise boat. This is a cruise boat. Now, this river, of course, you are moving upstream. Folks, you would know upstream. This is time, speed, distance, arithmetic. So I'm trying to give you an example from the real life. So you go upstream and then you come back downstream. All right. If I tell you that the river speed is 3 kilometers per hour and the time that you took to cover this was 6 hours. Okay. So I have given you two information, as you can see. I think one more information I'll give you, which is the distance that you traveled. It will be equal because you're traveling in a cruise boat, you're going to some point, you're seeing something beautiful and coming back. The distance, let's say, is 20 kilometers. Okay. Now, what's the idea about this? What's the story? The story is that you come back. So you come back to the starting point, and the driver tells you that the speedometer, okay, the speedometer is not working. What does the speedometer do? You have to find out the speed of the boat. Okay. So take some time and tell me what do you think should be the speed of the boat? Can you find out the speed of the boat? You have done time speed distance. Okay, I'll give you a hint. So let's say the distance is 20. You go upstream. So if the speed of the boat is s, I've assumed it. So let's assume it as s. So you're going upstream, which means s minus 3. This is distance. This is time. Distance upon time. Okay, and then you come back. So plus 20 upon s plus 3. Essentially, this is the time that you took to move upstream. And then you came back. You have to go home. So this is the time you took to come back. And this is known to you as 6 hours. Oh my God, this looks like an equation, right? This looks like a arithmetic problem now. Yeah, it is true. It is an arithmetic problem. But what if I tell you that if I just try and little bit solve it, something good happens. What is that? Let's see. Imagine if you were to solve it, you get s minus 3 whole square here, and you get 20 into s plus 60, and then again 20 into s minus 60. So this will essentially get cancelled out by 6. When you are going to solve this, I'm not going to solve this because the idea is just to give you uh, what a quadratic expression in real life would also be. So when you try to solve this and I tell you that find out the speed of s, you won't really get the actual any number for s, because the moment you open this up, this opens up as s square minus 6x plus 9. And then of course you cross multiply and so on. You end up getting something of the format ax square plus bx plus c is equal to 0. This is what you end up getting as. In this case, your s is the variable x. Okay, so this will come out something of the form some constant s square plus bx plus c, because speed was the variable. But this ax square plus bx plus c is the standard form of a quadratic, right? So this is a beautiful example because you can try and approach this, you can try and solve this for your own, and you will end up arriving at this format. And you will not really be able to find out the answer of x unless you know how to solve a quadratic equation, what is the formula, and so on. Okay. Now, please take a moment. Please take a moment to notice this. I'll halt for a minute so that you can also just see this example once more, what I talked about. So I just halt for a minute. This is the river example. Please take a note. I'll be back in a couple of minutes. Okay. So I'm back. So I hope you took a moment to sort of see what this example meant. This example is one of the many examples that I can tell you so that you relate this idea. But the goal, of course, is that we come at this part, and this is the objective. So we've come at this part, ax square plus bx plus c is equal to 0. And if you remember, in the very beginning, I talked about x square plus 4x, no, x square plus 2x plus 4. Okay. So in the very beginning, I wrote this equation x square plus 4x plus 4 is equals to 0. You can now try and compare this with the standard form. So standard form is ax square plus bx plus c is equals to 0. Can you tell me what a, b, and c are just by comparison? Okay, so if you compare, you get a is equals to 1. That is right. If you compare, you also get b is equals to 4. And you also get c is equals to 4. Very good. Now I'll tell you the quadratic formula. The quadratic formula is that x will be equal to minus b plus minus. Remember, we were stuck with finding out what the value of x would be. So this is the formula that you can actually approach to try and find out the value of x. Okay. I will come back to this with some examples and questions. But first, I will talk more about the basic format, which is ax square plus bx plus c. Okay. So let's understand what are the basic ideas of ax square plus bx plus c. Suppose if I tell you that something like x by 2 whole square plus 5x plus 2 is equals to 0. Can you tell me if this is actually a quadratic equation or it is not a quadratic equation? All you have to do is you have to just compare with the standard form ax square plus bx plus c. Now there is something that you will observe that the value of a will come out to be 1 by 4. And there's absolutely no problem with that. The coefficient can be 1 by 4. The coefficient can also be a negative. So the coefficient has to be a real number. That is the whole idea. But if I tell you that you have something like x to the power minus 2 plus x plus 4 is equals to 0, this will have a problem. Because if you want to compare it with ax square plus bx plus c, the x squared term is actually missing here. Okay. And anyway, this is not a polynomial because you cannot have negative powers. You also cannot have powers which basically are in fractions. So always remember that the definition of a polynomial and then a quadratic, it has to follow this standard form. Ax squared plus bx plus c. Okay. All right. So there are some more ideas that we can discuss, but whenever you get a confusion, always stick to this basic standard form where a, b, c can be real numbers, and it always need to have an x square at least. So for instance, if I just tell you that x square, this also works. Or if I just tell you that x square plus 2, do you think this works? Yes, it does. Why? I can tell the b is 0. So if I tell b is 0, you substitute b over here, all you get is something of x square, ax square plus c. And you see that this follows that. So this will still be a quadratic because the coefficient is real and it follows the standard form ax square plus bx plus c. But if I just tell you that 4x plus 5 is equals to 0, this is not a quadratic equation. because there's one problem. I think I forgot to mention this. I'm just mentioning it now. This a that we talk about, this a, this cannot be zero. So all real numbers except zero. Otherwise, you will not have a term with the highest power, which is 2ax square. So the moment this is the condition for a quadratic. You can have b and c have zero, that is okay. But a, b, c has to be real, of course. And this a cannot be zero. Otherwise, it won't be a quadratic. So this is the case example where the coefficient a becomes zero. So this is not a quadratic equation. So very useful point. Please note this idea as well. Uh, that a cannot be zero, and then you have to always see what ax square plus bx, what is the value of b, what is the value of c, and then there is of course going forward you will see how to use that. Okay, what I'll do now is I will tell you that there are some quadratic equations where you can approach this with with an easier technique. So for instance, this is the first question. Can you try and see how I can approach? So firstly, x square minus x minus 12 is equals to 0. Does it relate to ax square plus bx plus c is equals to 0? Cross check. This is the standard form. A is equals to 1. Okay. If you cross check, a is equal to 1, b is equals to minus 1, and c is equals to minus 12. So it is a quadratic equation. It's an equation because we are equating it to something, right? Okay. Now, there is this idea that you learn in school where you take the middle term and you can actually split it into two terms. Okay. Now, what I have done over here is I have split it into minus 4x and plus 3x. Okay. Please check once what I have done. I have basically split them into two parts. One is the minus 4x part and the other is the plus 3x part. Are they apples or are they, are they apples and oranges? They both are apples basically because why? Because this is x to the power 1, x to the power, they're like terms. So we can actually add them. Now what happens if you add them? If you add minus 4x and plus 3x, you get the same minus x. Now why did I choose minus 4 and plus 3? Okay. The reason why I chose minus 4 and plus 3 is because the constant term is minus 12. So what I'm trying to do is I'm trying to kind of break them into two factors. I'll tell you shortly what factors are, so that when they multiply, they produce this. So just imagine if I write this x square minus 4x plus 3x minus 12. What I've done currently is that I've written it as x square minus 3x minus 4x plus 3x minus 12 is equals to 0. Can I take x common? Yes. It becomes x minus 4. Remember, I want to make it into factor form, so I'll have to repeat this, and you will see just be concentrated here. You will see why I've done that. So x plus 4 can now be taken out because this is one term and this is the next term. Both of them have something common, which is x minus 4, sorry, x minus 4. And then it comes as x plus 3 into is equals to 0. So this is like what I'm doing is like 5 into 0 is equal to 0. Or if it were the case of numbers, 5 into 4 is equals to, let's say, some numbers 20. Here the number is 0, of course. Essentially, it's like numbers, but this is, of course, it's like some x plus some constant, x plus alpha you can call, x plus a you can call, okay, some constant, right? That's what you're doing. Because when you open this up, what will happen is you will get the same form. And do you know why I took minus 4 and plus 3? Because just look at what this is and what this is. Whatever you take it as here will come across as A and B. And what happens when you open these brackets? Right? Go back. What happens when you open this bracket? This A into B term will be multiplied and come as one term. and that is what we want. Okay, that's the idea. The idea is to try and bring them to two factors, and such the a and b will be such that it multiplies and gives me the constant term, right? Okay, wonderful. So let's do one thing. We'll take one more example where possibly you can, and this is slightly easier one. So you take this example as y square plus 12y plus 36 is equals to 0. So the question, even this time remains same. What you have to do is you have to try and bring them into two factors, something like y plus something into y plus something, and so on. So I'll give you a minute. Please try and see if you can get them into two factors, just like we did earlier, right? I brought them into x minus 4x plus 3 form. Can you try and do something that will sort of bring them? So the question, of course, is y square plus 12 by 36. The hint, if you want to give me to give the hint is split the middle term. This is your hint, my friends. Split the middle term. Yeah. So let's see what happens. This is the middle term. I have to split them into two terms such that when I add them, I need to get them this only. But also when I multiply the coefficients, I should get this when I multiply the coefficients. And let's see what happens if I do it in the form of 6y and 6y, because 6 into 6 gives me 36. And also when I add 6y and 6y, I end up getting 12y. So what happens if I write it as y square plus 12y plus 36 is equals to 0. So it will probably be written as y square plus 6y plus 6y plus 36 is equals to 0. Yeah, okay. Can I take something common? Maybe I can try. So I can take y common. I get y plus 6. And then because I want to sort of bring them into two factors, so I can also write it as multiplication of two expressions, I mean. So plus 6 is equals to 0. This gives me y plus 6 into y plus 6 is equals to 0. Take a note and see how I've followed the very steps that I told you before in the earlier example, where I just took the middle term. I sort of thought, how can I split them so that the coefficients are when I add them, I get the same term, middle term. But when I multiply the coefficients like 6 here, 6 multiplied by 6 should give me the constant term. And then I sort of end up with y plus 6 into y plus 6 is equals to 0. And you can also tell this as y plus 6 whole square. But currently we'll not go there. Can you now tell me what is the value of y? What do you think should be the value of y? For you're multiplying two things, and for the product, for the result to be 0, see, one of them has to be 0. Y plus 6 has to be 0. In this case, y plus 6, so y is equals to minus 6. This is your answer. So what I've really done is I can use this approach also and get an answer. This is simpler, of course. So feel free to use this as well. But we'll take one more example where there is slightly more on the same aspect. So let's take one last example on this idea. So imagine question number 3. If I tell you 3x square minus 2x minus 8 is equals to 0. But in this example, if you notice, this term a is not equal to 1, it's actually equal to 3. So this means that the approach that we did earlier about trying to split this term, you will have to be careful in this case. In this case, when you are splitting the term, what should happen is that the two terms when multiplied should be equal to not just 8, but should be equal to c, which is the constant term, into a. So the splitting should be such that when you multiply, it should be equals to 3 into minus 8, which is equals to minus 24. So you have to split in that fashion. Otherwise, it will be very difficult for you to get the answer. So I think this case, I'll give you in this example you can try, but I'm not sure if you will be able to get the integer values. So I'll give you one more example. You choose which one to sort of use the approach. So the other example is, as you can see, a is not 1 again, and I'll give you a constant term, something like maybe 6, and the middle term as 4, 7, sorry. Just try and see what I just discussed about splitting and factorizing, or breaking them into two terms, to so that you can actually factorize and get the answer for x. So you have this example. The difference in this case is that the value of a is not equal to 1, it's actually equal to 2, and you can have to use the same technique. How do you do that? Okay, so we'll take this middle term. If I split them into 4x and 3x, just notice what really happens when you add 4x and 3x. You should be able to get the value 7x, which is what we want. And what happens when you multiply these two coefficients? I think you should be able to get the value, not this, but constant into a. 4 into 3, constant into a. So let's try if this works or not. So I have told you, I write this as 2x squared plus 4x plus 3x plus 6 equals to 0. So I can take out 2x, I get x plus 2. I want to factorize, so I write 3. What I get is 2x plus 3 into x plus 2, which is the common thing, is equals to 0. So that is very good. I have been able to take out the common term, x plus 2. I have the two factors. Why don't we just solve it now? If this 2's product is 0, either x plus 2 is 0 or 2x plus 3 is 0, because it is very obvious. So x is equals to minus 2 or 2x equals to minus 3. And therefore now you have a value of x. But why do I get two values here? Yes, you will get two values here because in a quadratic equation, the real values of x can be 0 or 1 or 2. So in a quadratic equation, the real values of x can be 0 or 1 or 2. If you look at this example, which we did before, I only got one value, y is equals to minus 6. That is the only value I got. But if you were to look at this example, I'm able to get x equals to minus 2 and x equals to minus 3 by 2. I'm getting two values. So this is what you need to know about the nature when it comes to quadratic equations. Okay. So what? Just a quickly overview of what we have done. Quick recap, basically. So we have done how to identify the standard form. A quadratic equation has a standard form, ax squared plus bx You need to know whether a quadratic equation is in the standard form or not. Don't misidentify. I mean, you have to be you have to be understanding that a cannot be zero, for example. Then what we did is we came to this idea that we can get the value of x by factorizing, which is splitting the middle term. And this some of you might know, some of you might not forgotten and so on, but it's fine. There's one way you can basically solve these equations. Uh, I'll give you, we'll move to the next segment. I think I'll end with, I'll give you some more questions where you can sort of, again, the basic concept itself, we have to identify how to solve these questions. So if I have this question in front of you, how will you solve? And if I have one more question, let's say 1 by 10z square plus 19z plus 6 equals to 0. Now, we are not dealing with factorization anymore. This question is more like maybe you can use some common sense approach. So I'll give you some time to think. But this question, you will have to uh, think very carefully how you can use the approach of factorization. So you have 10z square plus 19z plus 6. Look at A, look at C, and maybe you can split the middle term. Figure out what can be the value of z and figure out what can be the value of x. 5x cubed minus 5x squared minus 10x equals to 0. I'll give you a hint. Convert this into a quadratic first. Currently, it's not a quadratic. So maybe you can think of taking x, cancelling x, and you may get a quadratic. The quadratic will become x squared minus x minus 2 is equals to 0. Okay. You have to convert them into this form by cancelling 5x from all the three terms. And then it will be mostly be a repeat scenario where you will repeat this. So if I take example of x squared minus x minus 2 is equal to 0, look at the middle term. What do you think should be the two coefficients? Yes. And now you can take x outside, you get x minus 2, you get x minus 2. So you have x minus 2. Again, the values of x are there are two real values of x, which is x equals to 2 and x equals to minus 1. So this is how you can use at times your common sense and do with the questions. So I've just done what I did in the previous questions, and I was able to solve for the values of x. In the original form, it is 5x cube actually. This is actually cubic. So when you have the luxury, because of you have 0, you have the luxury of converting them. But the moment I had not a 0, like a 10 also, or like a 20 also, this will not be possible. Why it's not be possible? Go very basic. Ax square plus bx plus c. You have now not just ax square, but you have a cubic nature polynomial. Okay. We'll go to the last question, which is about 10z square plus 19z plus 6 is equals to 0. What is the coefficient? Is it equal to 1? No. So we'll convert them into an appropriate form such that when you multiply the coefficients, you get constant into a 15 into 4, 6 into 10, 15 into 4. So 10 into 6 is how much? 60. 15 into 4 is also 60. So this hopefully should work. And then you have the same constant term. Now I can write this as 10 z square plus 15z plus 4z plus 6 is equals to 0. What happens if you add these two terms? You should always get the middle term with the sign. So you can take 5z, you get 2z plus 3, repeat it. What will you multiply so that you get these two terms? Maybe this. Now you get 5z plus 2 as 1, and you had taken 2z plus 3 as your common part. Is it done? You have two expressions multiplied, you factorize this. Yes, it is. So you can take any one of them as equals to 0 and you get the value of z, right? So this is a very beautiful example where you saw multiple ways in which you could have approached this and solved a quadratic equation. So I'll see you again hopefully with the next topic. Till then,